Hi students, this is Parthiban here, handling 12th standard mathematics, Tamil Nadu board. Welcome you all to Vidyalakshmi YouTube channel. In the previous video, we had seen that evaluation of definite integral by using Riemann sum. There we had seen three methods of Riemann sum. First one, Riemann left sum, then Riemann right sum. Finally, we had seen that Riemann midpoint sum formula. So now it is a time to go for method 2. Method 1 was Riemann sum. By using Riemann sum, we had calculated integral a to b f of x dx. Now it is a time to go for method 2. Method 2 is called limit sum formula. New concept coming up. By using that, let us see how to find out the value of the definite integral a to b f of x dx. Here is the method 2 formula. Limit formula to evaluate integral a to b f of x dx is nothing but integral a to b f of x dx equal to limit n tending to infinite b minus a by n summation ranges over or from 1 to n f of a plus b minus a into r by n. Close the bracket. Students, you have to be thorough with this formula. Whenever they ask us to evaluate the definite integral by using limit sum formula, you should write this formula. So you memory it. 2 or 3 times you write, go through your memory. So limit n tending to infinite b minus a by n summation ranges over or from 1 to n f of a plus b minus a into r by n. Immediately let us go to the problem. Example number 9.2. Let us evaluate integral 0 to 1 x dx as the limit of a sum. You see that you have to see the method. Previously we dealt with Riemann sum, but here it is simply limit sum. Riemann, the word Riemann is missing out there, so limit sum formula here we should utilize. Okay, let's go to the problem straight away. Okay students, first let us select what is a, what is b, what is f of x. So let's go to the problem. Solution. So as we saw in the previous video, lower limit is taken to be a. What is a here? A equals 0. What is b here? 1. B value equal to 1. What is our f of x? X. F of x equal to x. Now let us write limit sum formula. Therefore, limit sum formula is integral a to b f of x dx equals limit n tending to infinite b minus a by n summation ranges over or from 1 to n f of a plus b minus a into r by n. Like this you have to memory the formula. Okay, let us take it to be 1. Let us calculate the required thing to go for the substitution here. Okay, b minus a. What is b minus a here? Here itself you can calculate it. B minus a is nothing but b value 1, 1 minus 0, which is nothing but 1. So b minus a is 1. Next we should calculate the functional value for a plus b minus a into r by n. So let us consider the term separately. Take it separately. F of a plus b minus a into r by n. That is nothing but f of a. What is the value of a here? 0. 0 plus, open up the bracket, b value is 1 there. So 1 minus a value 0 into r by n, and this is nothing but f of, leave 0, 1 minus 0, 1 into r by n, f of r by n. Students, here you see that f of x is given to be x. What is our f of x? X itself. Whatever the input you give, same output we are getting. 1 means output 1, 2 means 2. Likewise, what is the answer for f of r by n? Simply r by n. So we got the functional value at this as r by n. Now all things are ready to go for the substitution. Let us go for the substitution now. Let us go for the substitution. Therefore, equation 1 certainly implies that integral lower limit. What is our lower limit? What is the question? Lower limit 0, upper limit 1, function x. So 0 to 1 x into dx, which is equal to limit n tending to infinite b minus a. What is the value of b minus a? 1. 1 by n, summation ranges over r from 1 to n, f of a plus b minus a into r by n. What is the answer for that? R by n. So substitute here r by n. So r by n, which is nothing but limit n tending to infinite 1 by n. Students, you see that the summation depends only on r. R is going to change. When you give r equal to 1, 1 will come up. 2 means 2 will come up. 3 means 3 will come up. So the summation depends on r only, not on n. So this is the constant, that is, it is independent of r. So you can take it outside. Whenever the interior is independent of r, you can take it outside of the sum. So here it is 1 by n, take it outside of the sum. So 1 by n, summation r equal to 1 to n r. Students, remember one thing here. In 10th standard, you could have studied these facts. Please remember these things. Please remember that summation r, summation ranges over r where r equal to 1 to n. If you expand this, you are getting that. Give r equal to 1 here, 1. Summation means addition. Give 2, 2, 3, plus etc. etc. Final value n. Last value of r is what? N. N. What is the answer for this? Actually, this is nothing but sum of the first n natural numbers, which is nothing but n into n plus 1 by 2. 10th standard result. Secondly, summation ranges over r from 1 to n, r squared. That is 1 square plus 2 square plus etc. etc. plus n squared. This is sum of the squares of the first n natural numbers. Can you guess what is the answer? Which is given by the formula n into n plus 1 into 2n plus 1 divided by 6. And thirdly, summation r equal to 1 to n r cube, which is nothing but 1 cube plus 2 cube plus etc. etc. n cube, which is equal to n into n plus 1 by 2 the whole squared. This is the sum of the cubes of the first n natural numbers. Okay. Sometimes we may have to use summation ranges over r n equal to 1 to n. 2r minus 1. 2r minus 1. When we give 1 here, 2 minus 1, 1. 1 will come up. Plus, when you give 2 here, 2 2s are 4. 4 minus 1, 3 will come up. 3. Actually odd numbers. Then 5 plus etc. etc. Finally, you will be getting 2n minus 1. What is the value of final value of r? N. When you put n here, 2n minus 1 will come up. Actually, this represents sum of the first n odd numbers. Can you guess what is the answer for that? Which is nothing but n squared. Which is nothing but n squared. Okay, sometimes we may have a situation like this. Summation ranges over r from 1 to n. Simply you will be getting 1 here. Simply you will be getting 1 here. Which means the interior is independent of r. Independent of r. Whatever the value you give for r, output will be remaining 1, 1, 1 like that. So when you give r equal to 1, 1. When you give r equal to 2, again 1. plus etc etc. When you give r equal to n, again 1. How many ones are there? N ones. If you add 2 ones, you are getting 2. If you add 3 ones, you are getting 3. If you add 4 ones, you are getting 4. Likewise, here how many ones we are getting? N ones. So answer is what? N. So students, please be thorough with these results. At any stage of the problem, you will be required these results. Okay, let us get back to the original problem. This is nothing but limit n tending to infinite 1 into 1 by n squared into, students, have a look at this. Have a look at this. Summation ranges over r from 1 to n, or this case matches with first result. You see that first result, summation r equal to 1 to n, or the expanded form is this. What is the answer? Straight away you can take that form. What is that? N into n plus 1 by 2. If you want to expand, you can expand it. Go for one more step. Give r equal to 1 plus r equal to 2 3 plus etc etc. Finally you are getting n. Okay, and this is nothing but limit n tending to infinite 1 by n square into, what is the answer for this? N into n plus 1 by 2. Here it is, n into n plus 1 by 2. Okay, next limit n tending to infinite 1 by n square into, you got n there, into, from these two terms take n outside. Take n outside, you are getting n into, if you take n outside, here it will become 1, this will become 1 by n whole divided by 2. Here you can see that n into n squared, n square getting cancelled. You may ask one question, sir, why you are taking n outside? See, if you don't take n outside, straight away if you substitute infinite here, infinite into anything, infinite will come up. Infinite. By here also if you put infinite, infinite square is infinite, which is indeterminate form. This is the thing you are going to study in chapter 7. In chapter 7, infinite by infinite, 0 by 0, 1 by infinite. So these are called indeterminate forms, meaningless. So for that, we need to evaluate that indeterminate form. For that purpose, I am taking n outside so that n square getting cancelled. Now you are getting a finite answer as the output. I hope you understand this step. Okay. Okay, let's get back to this. So what you are getting here? Limit n tending to infinite. What are the remaining things? There 1 plus 1 by n divided by 2. Now you substitute infinite. In the place of n, take infinite. So 1 plus 1 by infinite whole divided by 2. What is 1 by infinite? 0. 1 by infinite is what? 0 by 2. 1 plus 0, 1 by 2. So eventually answer is 1 by 2. So students, step by step easily you can understand. Please be thorough with these summation results. Okay. So recap. As soon as you read the problem, gather what is a value, what is b value, what is f of x, and calculate what is b minus a. Then write the limit sum formula correctly. Students, you should memory this formula. So if you commit any mistake in writing this formula, entire problem will collapse. So you have to take utmost care in writing this formula. Then you are focusing on f of this. You are calculating the answer for f of this. Substitute for a, substitute for b, simplify. And by using the given function f of x equal, here it is f of x equal to x. You are getting the output same as the input. So r by n means r by n. According to the given function, it will change. Then substitute these things in the formula, in the limit sum formula. Whenever the interior is independent of r, you take it outside, then you expand this. The expansion will be coming under any one of these types. Then use the results accordingly. Then simplify. Students, you don't go for substitution n equal to infinite whenever you are getting n is on denominator. Until you are getting n on denominator, please don't go for substitution. Though if you go for substitution, you will be getting indeterminate form. Infinite by infinite form will come into play. To avoid it, please take n outside, so that n square will get cancelled. Then you go for, see here, no denominator, that is n is vanished, no n involved on denominator. Then you substitute n equal to infinite. So finally answer is 1 by 2. So I hope you understand this problem. Let's go for another sum. 9.3. Let's have a look at it. Evaluate integral 0 to 1 x squared dx as the limit of a sum. So method is clearly mentioned there. We should use limit of sum formula. As we done in the previous problem, we need to gather the required things. What is a, what is b, what is f of x. So like that we have to gather all the things, then write the formula, go for the substitution, you can get the answer. Okay, let's go for the solution. So what is a here? A is the lower limit, which is 0 here, a equals 0. What is b here? 1, b equal to 1. What is f of x here? F of x equal to x squared. Then you have to calculate b minus a. What is b minus a here? B value is 1, a value is 0. So 1 minus 0 is what? 0. Next we should write limit sum formula without any mistake. Therefore, limit sum formula. Limit sum formula is nothing but integral a to b f of x dx equals limit n tending to infinite b minus a by n summation ranges over r equal to 1 to n f of a plus b minus a into r by n. Students, you should memory this formula. If you commit any mistake in writing in this formula, entire problem will collapse. So you just write down this formula thrice or 4 times, just memory. Now let us calculate f of this value. You consider this. F of a plus b minus a into r by n, which is equal to f of, what is the value of a here? 0. Plus b minus a. What is the value of b minus a? B minus a, in fact, 1. It is 1 actually. I'm sorry. It is 1. Because 1 minus 0 is what? 1. So 1 should come up there. So 1 into r by n as such. R by n. Close the bracket. Which is nothing but f of r by n. Leave 0, 1 into r by n, r by n. Now we should utilize the given function to get the output. What is the given function there? X squared. You see, whatever the input you give, the output will be the square of it. 1 means 1 square will come up. 2 means 2 square will come up. 10 means 10 square will come up. Likewise, here what is our input? R by n. So what is the outcome? R by n the whole square. R by n the whole square. Insert the square, you are getting that r square by n square. So students, we got the things to go for the substitution. Let us go for one now. Put all these things, a, b, b minus a, functional value, everything you have to substitute in equation number 1. Let's go to that. So equation number 1 certainly implies that 0 to 1 x squared dx equal to limit n tending to infinite extending to infinite b minus a. What is the value of b minus a? We got it as 1 by n, summation ranges over r from 1 to n, f of functional value. What is the functional value there? R square by n squared. You see that functional value, which is r square by n squared. You take it here, r square by n squared. Students, as I said in the previous problem, this summation depends on r only. Summation ranges over r. So independent of r must be taken. R is the only thing going to change. When you give 1, 1 square. When you give 2, 2 square. R is the thing which is going to be changing. N square will be remaining same. So that thing can be taken outside of the summation. So if you do so, you are getting limit n tending to infinite. Already 1 by n is there. this 1 by n square will come up as 1 by n squared. Summation ranges over r from 1 to n r squared. And this is nothing but limit n tending to infinite 1 into 1 n into n squared n cube. You just expand this summation, expand it, give r equal to 1, you are getting 1 squared. Then give r equal to 2 squared, plus etc etc. What is the last value of r? N. So you are getting n squared. Okay. And this give us limit n tending to infinite 1 by n cube. Students, can you guess what is the formula for this? Can you remember? Actually, this represents sum of the squares of the first n natural numbers. Can you guess what is the answer for that? See, in the first problem, I gave all the things. Sum of the first n natural numbers, sum of the squares of the first n natural numbers, cubes, odd numbers. You got everything here. But here we have to utilize this formula. 1 squared plus 2 squared plus etc etc n squared, which is given by n into n plus 1 into 2n plus 1 by 6. You should memory all these things. All these things you could have studied in 10th standard. You just remember them. So let us substitute that formula here. So you are getting n into n plus 1 into 2n plus 1 whole divided by 6. Students, don't substitute n equal infinite. I strongly told that whenever you are getting n on denominator, please don't go for substitution. Though if you go, you will be getting infinite by infinite form. So we need to take n outside from each factor. So let's go to that. So limit n tending to infinite 1 by n cube into, already one n is there, keep it as such. From this factor take n outside. So n into, here if you take n, 1 plus 1 by n will come up. That's over. Similarly, from the second factor you take one more n. If you take n outside, here you are getting 2 plus 1 by n whole divided by 6 is there. Students, here you see n into n squared into n cube. So n cube getting cancelled. So what do you have remaining there? What do you have remaining? That is equal to limit n tending to infinite 1 plus 1 by n into 2 plus 1 by n whole divided by 6. Now you put n equal to infinite. Wherever you have n, replace it by infinite. What you are getting there? 1 plus 1 by infinite into 2 plus 1 by infinite whole divided by 6. Since you know that 1 by infinite is what? 0. So 1 plus 0 into 2 plus 0 whole divided by 6. Which implies that 1 into 2 by 6, which is nothing but 2 1s are 2, 2 3s are 6. So students, eventually you are getting the answer to be 1 by 3. So step by step you can do it. But you have to take written practice. You should write. Many of the students just seeing the problem. No, you should not do. Take the problem, write the formula, step by step you work out. Then only you will come to know wherever you are committing the mistake. See, without knowing this formula, what is the formula for this? This is the formula. Without knowing this, you cannot continue the problem. And the simplification also, you should write. Then only you will be getting the right flow. So have a glance, as usual way, gather A, gather B, gather f of x, write the formula, obtain the answer for this, then go for the substitution, simplify carefully, you are getting the answer. I hope you understand this problem. Now it's the time to go for another sum. Have a look at example 9.4. It's a 5-mark question, lengthy one, important sum. You may expect this sum in a 5-mark section. Have a look at it. Evaluate integral 1 to 4 2x square plus 3 dx as the limit of sum. As the limit of sum. Method is clearly mentioned there. So let us proceed as usual way. Solution. Students, tell me what is A here? A is the lower limit, which is 1 here. A equal to 1. What is B there? 4. What is f of x here? What is it? 2x square plus 3. Then we should calculate b minus a. What is b minus a? B value 4, a value 1. 4 minus 1, 3. Now let us write the formula for limit sum. Therefore, limit sum formula is, what is that? Integral a to b f of x dx is nothing but limit n tends to infinite b minus a by n, summation ranges over r from 1 to n. What is the next thing? F of a plus b minus a into r by n. So as usual manner, let us take it to be equation number 1. Okay. What is the next thing? We need to compute the value for this, f of this thing. Take it out. So f of a plus b minus a into r by n, which is nothing but f of a. What is a value? 1. What is b minus a? B minus a is what? 3. Take it here. 3 into r by n. R by n. Okay, students. Now this is our input, f of x. What is our f of x? What is our f of x? Here something is somewhat bigger. In the previous sums, in the first sum you got f of x to be x, simply x. In the second sum it was x squared. But here it is not the case. Function changes little bit tougher. F of x is equal to 2x cube plus 3. See, this x will become as x cube, then you multiply it by 2, then add 3 with the resultant. So this is x, this is our x, f of x. So what is the output? 2 should come first. 2 into x cube. What is our x here? What is our x? 1 plus 3r by n. Actually the function is 2x square 2x square. I take it there as cube. It is wrong. X square. So 2x square plus 3. Okay. So 2 into x is 1 plus 3r by n whole power 2 plus 3. I hope you understand this. Again I repeat. Function is 2x square plus 3. In the place of x, 1 plus 3r by n is there. Just substitute there. So 2 into that thing plus 3. Now let us expand this carefully. 2 into, this is in the form of a plus b whole squared. What is the formula for that? A squared. So 1 squared plus b squared. What is b here? 3r by n whole squared plus 2ab. 2 into a. What is a? 1. What is b? 3r by n. Close it. Close the entire thing. Plus 3. Don't forget to take that 3. Plus 3 should come. So a squared plus b squared plus 2ab. At last you are getting 3. Let us go to the next page. Okay. 2 into 1 square is what? 1. 1 square is 1 plus, what is the next term? 3r by n whole squared. If you insert square, 9r square by n square will come up. 9r square by n square will come up plus if you multiply these things, 2 3s are 6, 6r by n. 6r by n, at last you are getting 3 there. Okay. Next let us apply 2. Multiply this factor by 2. So this is nothing but 2 1s are 2 plus 2 9s are 18. 18r square by n square plus 2 6 are 12. 12r by n plus 3. Students, you can add these two numbers. 2 plus 3, 5. So 5 plus 18r square by n square plus 12r by n. This cannot be simplified further. R square or 5, all are unlike terms. It cannot be simplified further. Now substitute this answer in equation number 1. Therefore, equation 1 certainly implies that. What is equation number 1? What is our equation number 1? Here it is. Left side, it is a given problem, 1 to 4, 2x square plus 3. Integral 1 to 4, 2x square plus 3 into dx, which is equal to limit n tending to infinite, b minus a. What is our b minus a? 3. 3 by n. You see it? What is our b minus a? 3. 3 by n. Summation ranges over or from 1 to n. Summation ranges over or from 1 to n. F of functional value. What is the functional value you got there? To take it here, 5 plus 18 r square by n square plus 12 r by n. 12 r by n. Let us simplify it carefully. This is the lengthier part actually. So that is equal to limit n tending to infinite. You can apply 3 by n inside also. Apply it. You can apply it. So summation ranges over r equal to 1 to n. If you apply 3 5s are 15, 15 by n coming up, plus 3 18s are 3 8s are 24, balance 2, 3 plus 2 5, 54 by n into n squared, n cube, there it is r squared, plus 3 12s are 36 r by n into n, n squared. Okay, next let us go for a split. You just apply summation to all these terms. Let's apply it. Okay. So that is equal to limit n tending to infinite. Careful, summation ranges over r equal to 1 to n. What is the first term here? What is the first term? 15 by n. 15 by n plus summation ranges over r 1 to n. What is the second term you got there? Second term, 54 r square by n cube. 54 r square by n cube. Finally, summation r equal to 1 to n. Last term, 36 r by n square. 36 r by n square. Close it. See, as I told you already, summation depends on r only. Independent of r can be taken outside. Okay, let's go for that. Limit n tending to infinite. See here, interior entirely independent of r. No r involved. No r involved. So entire thing can be taken outside. So 15 by n summation r equal to 1 to n. If you take entire thing, 1 will be there. 1 into 15 by r, 15 by r. Plus, what is independent of r here? 54 by n cube. 54 by n cube, take it outside. Summation r equal to 1 to n r squared. And what is independent of r here? 36 by n squared. Take it out. 36 by n squared, summation r equal to 1 to n into r. And next, limit n tending to infinite, 15 by n. Students, already I told you, you should go for the expansion. See, 1 is independent of r. Whatever value you give for r, 1 will be coming constantly. So when you give r equal to 1, 1 will come up. R equal to 2, again 1 will come up, etc, etc. When you give n also, 1 will come up. How many ones are there? N ones are there. Plus 54 by n cube. You expand this, give r equal to 1, so 1 squared. Give r equal to 2, 2 squared, and so on. Finally, give r equal to n, n squared. Close it up. Plus 36 by n squared into, the same way you expand this, give r equal to 1, so 1. Give r equal to 2, 2, plus etc, etc. Give r equal to n, n. Close it, close the entire bracket. Students, you got the results for all these summations. Answer for this you know. Answer for this you know. So in the first problem itself I gave all the results. Please tell me what are the results. Limit n tending to infinite 15 by n. What is the answer for this? 1 plus 1 plus 1 etc. How many ones are there? N ones. So what is the answer? N. How? If you add 2 ones, 1 plus 1, 2. If you add 3 ones, 1 plus 1 plus 1, 3. If you add 5 ones, 5. In the similar way, if you add n ones, n will come up. Plus 54 by n cube into, what is the answer for this? Sum of the squares of the first n natural numbers. Formula memory lerkano, which is n into n plus 1 into 2n plus 1 by what? 6. And the last term is that 36 by n square into sum of the first n natural numbers. What is it? N into n plus 1 by 2. Close this. Straight away don't go for n equal to infinite. All denominator n's must be vanished, must be cancelled. Until that you wait. So here n cancel. So limit n tending to infinite. What you are getting here? 15. N cube is there. So on denominator you should get n cube. For that you have to go for a little manipulation. Here you can cancel. 6 9s are 54. 6 9s are 54. So 9 by n cube into, keep that n as such. From the first factor take 1 n outside. So you are getting there 1 plus 1 by n. Okay. From the next factor you take one more n outside into n. If you take n, you are getting 2 plus 1 by n. I hope you understand this. Divided by what? N cube is there. Here you can see that n cube getting cancelled. Let us go to the last step. Here also you can cancel. 2 18s are 36. So 18 by n square into, here you should get n square on the numerator. N square is there. Already one n is there. From this factor take one more n. So if you take n outside, you are getting 1 plus 1 by n. Close the bracket, close the entire thing. Again you see that n into n square getting cancelled. Students, you see this step clearly. All denominator n's are vanished. No n is there on denominator. Now our root is very clear. Straight away you can put n equal to infinite now. Let's go to that. So this is nothing but 15. First term is 15. It is independent of n. N is not there. So 15 as such. Here 9 into plus 9 into 1 plus 1 by infinite. Am I correct? 9 into 1 plus 1 by infinite into 2 plus 1 by infinite. 2 plus 1 by infinite plus, what is the last term? 18 into 1 plus 1 by infinite. 18 into 1 plus 1 by infinite. Okay, this is nothing but 15 plus 9 into 1 plus what is 1 by infinite? 0. Into 2 plus what is 1 by infinite? 0. Plus 18 into 1 plus 1 by infinite again 0. So which is nothing but 15 plus 9 into 1 plus 0 1, 2 plus 0 2, 18 into 1 plus 0 1. So which is nothing but 15 plus 9 2s are 18, 18 1s are 18. What is the sum of these numbers? 18 plus 18 36, 36 46 51. So students, eventually answer for the given definite integral is 51. It is a 5-mark question. If you don't work out this problem, you can't do this. You take the problem step by step, you work out. The lengthier part is the last part actually. This part is the lengthier part. This is the part we got lengthy. So we are taking independent of our outsider. We are expanding. We are substituting the formula. You have to be careful here. careful here. If you commit a single mistake, the entire problem will collapse. So definitely this problem worth for a 5 mark question. In case any doubt with this problem, later you can clarify that. Okay students, I hope you understand this problem. Let's go for one more sum. And this is the last sum. Evaluate the following integrals as the limits of sums. Integral 0 to 1 5x plus 4 into dx. As usual way, let us proceed. What is a? What is a value here? A value 0, lower limit. What is b value there? 1. What is f of x here? This is our f of x, 5x plus 4. Easily you can do this. Easily you can get a 3 mark or 5 mark. Routinely we are doing the same type of problem. You will be getting the core idea. So you can do it. Then you have to calculate b minus a. B minus a. Our b value 1. 1 minus 0 is what? 1. Let us write limit sum formula. What is the limit sum formula? Tell me. Limit sum formula is that integral a to b f of x dx. What is the answer? Limit n tending to infinite b minus a by n summation ranges over r from 1 to n f of a plus b minus a into r by n. Let it be equation number 1. Next, what we should compute? You should focus on this part. Consider it. So f of a plus b minus a into r by n, which is equal to f of, what is our a here? A value 0 plus b minus a. What is our b minus a? 1. 1 into r by n. This is nothing but f of, leave 0, 1 into r by n, r by n. This is our f of x. How f of x acts? See it. Whenever you give input x, what is the output? 5 into x. That is, the x is multiplied by 5. Finally, we should add 4 with that. So, instead of x, you are getting r by n. So, what is the output? Tell me. 5 should come. 5 into x. What is x here? R by n. Plus 4. So, which is nothing but 5r by n plus 4. We got it? Let us substitute that answer in equation number 1. Therefore, equation 1 certainly implies that integral, what is the problem? 0 to 1, 5x plus 4. 0 to 1, 5x plus 4 into dx, which is equal to limit n tending to infinite b minus a. What is our b minus a? See the formula. B minus a is 1. 1 by n. 1 by n. Summation ranges over r from 1 to n. Function value. What is the function value you got there? 5r by n plus 4. 5r by n plus 4. Pure substitution. And let us simplify this carefully. Limit n tending to infinite. As I told you already, you can apply this n inside. You can apply it. Go for it. Summation r equal to 1 to n. If you apply 1 into 5r, 5r, n into n, n squared, plus 1 into 4, 4, 4 by n coming up. Now let us apply the summation. So that is equal to limit n tending to infinite. Put up the bracket there. Apply summation. Summation r equal to 1 to n 5r by n squared plus summation r equal to 1 to n 4 by n. So what is the next step we have to do? Independent of r must be taken outside of the sum. So this is nothing but limit n tending to infinite. Here what is independent of r? 5 by n squared. 5 by n square is independent of r. Take it outside of the summation. R equal to 1 to n r. Here what is independent of n? The entire thing is independent of n. No r involved. Take the entire thing outside. So 4 by n summation r equal to 1 to n. There you are getting 1. Now let us expand this as usual manner. Limit n tending to infinite 5 by n squared. Students, give 1 here. R equal to 1 means 1. 2 means 2. And so on. What is the final value of r? N. So n should come up. Close it. Plus 4 by n into, it is independent of n actually. Whatever value you give for r, 1, 1, 1 will be fixed there. So 1 plus 1 plus 1 plus etc. etc. 1. How many ones are there? How many ones are there? N times of ones. And you know the formula for these two expansions. This is the sum of first n natural numbers, which is n into n plus 1 by 2. This is nothing but n. Let us go for that. Let's go here. So this is equal to limit n tending to infinite 5 by n square into, what is the formula for this? N into n plus 1 by 2 plus 4 by n into, what is the answer for this? N. Close the entire thing. N getting cancelled. But here n is on denominator. You should manage to get n square on numerator. So that n square will be get cancelled. So n tending to infinite 5 by n square into, already you got 1 and n there, keep it as such. From this factor take n outside. So n into 1 plus 1 by n will come by 2 plus 4 is there. Here you see that n into n squared getting cancelled. So this gives us limit n tending to infinite. What are the things remaining you got there? 5 by 2 into 1 plus 1 by n plus 4. Now n has gone from the denominator. Now right time has come to substitute n equal to infinite. Go for it. Remove limiter. So 5 by 2 into 1 plus 1 by infinite plus 4. So which is nothing but 5 by 2 into 1 plus 0. 1 by infinite is what? 0 plus 4. So which is nothing but 1 plus 0, 1. So 1 into 5 by 2, 5 by 2 plus 4. 4 means 4 by 1. Go for a cross multiplication. 1 5s are 5, 4 2s are 8, by 2 1s are 2. So final answer is that 13 by 2. 13 by 2. Students, I hope you understand this problem. As usual manner, we have done this. Simple one. If you do 2 or 3 sums, you will be getting full flow. Easily you can understand this. And the last sum is there. This is a 5-mark question. It's a 5-mark question. As the possible gets more complicated, you will be getting more steps. And it is a 5-mark question. Here you see that function is not simpler. As f of x equal to f of x equal to x squared, f of x equal to 2x. Here something, the function is got big. So it is a 5-mark question. So let's proceed. Let's proceed as usual manner. Solution. Students, tell me what is a here? A value lower limit, which is equal to 1. What is b value? 2. What is our f of x? F of x equal to what? 4x square minus 1. Then you have to calculate b minus a. What is our b minus a? B value 2. 2 minus 1? 1. Now let us write limit sum formula carefully. limit some formula is that integral a to b f of x dx. What is the answer? Answer is that limit n tending to infinite. By now you could have thoroughd this formula. I think this is the problem number 5 we are doing. By now you could have completed, you could have thoroughd, you could have memoried this result. B minus a by n, summation ranges over r from 1 to n, f of a plus b minus a into r by n. Let it be equation number 1. Now let us consider this part as usual manner. So f of a plus b minus a into r by n, which is nothing but f of a. What is our a value? 1 plus b minus a. What is our b minus a? That is also 1 into r by n. Close it up. So this is nothing but f of 1 plus 1 into r by n, r by n. Okay, this is our x. This is our x, f of x. What is our f of x here? First you understand it. See, x means square coming up. Square coming up, you multiply it by 4. From the resultant you subtract 1. Again you repeat. X means the square should come up, multiply it by 4 and subtract 1. But tell me, what is the answer? 4 into x square. What is x here? In the place of x, what are you getting here? 1 plus r by n. R by n whole squared. At last you should subtract 1. And this is nothing but 4 into, expand this. This is in the form of a plus b whole squared. What is the formula? A squared, which is 1 squared, plus b squared, which is r by n whole squared, plus 2ab. What is a? 1 into b. What is our b? R by n. Close it. Close it. Minus 1. Students, simple expansion, a plus b whole square expansion. Let's go to another page. So which is 4 into, what are you getting there? 1 square 1, r square by n squared, 1 plus r square by n squared, plus 2 1s are 2, 2r by n minus 1. 2r by n, close the bracket, minus 1. Now as usual, let us apply 4 inside. 4 1s are 4, 4r square by n squared, plus 4 2s are 8, 8r by n minus 1. Students, 4 minus 1. What is 4 minus 1? 3. So 3 plus 4r square by n squared plus 8r by n. So we got the functional value as well. Now let us put this answer in equation number 1. Therefore, equation number 1 implies that integral, what is our problem? Integral 1 to 2 4x square minus 1. 1 to 2 4x square minus 1 into dx, which is equal to limit n tending to infinite b minus a. What is our b minus a? 1 by n. Summation ranges over r equal to 1 to n. Function value. You see the formula? B minus a 1 by n summation function value. We got it there. What is the function value? It is here. We just substitute 3 plus 4r square by n squared plus 8r by n. Now as we did in the previous problems, apply 1 by n inside. So which give us limit n tending to infinite, apply 1 by n. Summation r equal to 1 by n, 1 to n, 1 into 3, 3 by n, plus 1 into 4r square, 4r square by n into n square, n cube, plus 1 into 8r, 8r, n into n what? N squared. Okay, now what is the next step? You have to apply summation inside. Let's go to the new page. So limit So limit n tending to infinite, apply the summation 3 by n. Summation r equal to 1 to n 3 by n plus summation r equal to 1 to n. What is the next term you got there? 4r square by n cube. 4r square by n cube plus summation r equal to 1 to n. What is the last term? Last term is that 8r by n square. 8r by n squared. Okay students, what is the next step we have to do? We need to take out independent of r. Independent of r must be taken outside. So that is equal to limit n tending to infinite. See, entire thing is independent of r. No r involved. Take entire thing outside. 3 by n summation r equal to 1 to n. 1 is there. Plus, what is independent of r here? 4 by n cube. 4 by n cube. Take it outside. 4 by n cube summation r equal to 1 to n r squared. Here what is independent of r? 8 by n squared. So 8 by n squared summation r equal to 1 to n r. Okay, what is the next step we have to do? We need to go for the expansion. Let us expand. Limit n tending to infinite 3 by n into, students here 1 it is a constant, it is independent of r, so 1 will come up, so 1 plus etc 1. How many n's? How many ones? In fact n ones, plus 4 by n cube into, expand this, what you are getting there? 1 square 1, actually 1 square 2 square plus etc, at last you are getting n squared, plus 8 by n square into, give r equal to 1, so 1 plus 2 plus etc plus n, close it, close the entire bracket. Now you know the formula for all these expansions. This is n, you got the formula for this, and you got the formula for this as well. Okay students, and this is nothing but limit n tending to infinite into 3 by n. What is the answer for this? N. How many ones are there? N ones. Plus 4 by n cube into, what is the formula for this? You got it already. N into n plus 1 into 2n plus 1, 2n plus 1 divided by 6 plus 8 by n square into, what is the sum of the first n natural numbers? N into n plus 1 by 2. Close the entire bracket. Now wherever cancellation possible, you should go for that. n getting cancelled. Here 2 2s are 4, 2 3s are 6. Here 2 4s are 8. And this is nothing but limit n tending to infinite. What you are getting here? 3 is left out. Plus, student, as I told you already, on denominator no n should be left out. N cube. So on the numerator you should manage to get n cube. So 2 by n cube into, already 1 n is there. Okay. From this factor take n outside. So n, if you take n, you are getting 1 plus 1 by n. From the next factor also you take one more n outside. If you take, you are getting 2 plus 1 by n. Whole divided by what? 3. Here you can see that n cube getting cancelled. And here 4 by n squared. So n square is there. We should manage to get n square on the numerator. 1 n is there already. So take one more n from that factor. Take one more n. So if you take n, you are getting 1 plus 1 by n. Close it. That's it. Close the entire bracket. Close the entire bracket. Here you can see that n into n squared, n square getting cancelled. So now let us write the balance things carefully. What are the balance you are getting here? Limit n tending to infinite, you are getting 3 plus what are the factors left out? 2 into 1 plus 1 by n, 2 plus 1 by n by 3. 2 into 1 plus 1 by n, 2 plus 1 by n whole divided by 3 plus 4 into 1 plus 1 by n. 4 into 1 plus 1 by n, close it, close the entire bracket. And this is nothing but, now it is the right time. See, no n involved on denominator, wherever you have n, replace it by infinite. So 3 plus 2 into 1 plus 1 by infinite, 2 plus 1 by infinite divided by 3 plus 4 into 1 plus 1 by infinite. And this is nothing but 3 plus 2 into 1 by infinite is what? 0. 2 plus 1 by infinite is 0 divided by 3 plus 4 into 1 plus 1 by infinite is what? 0. So which is nothing but 3 plus 2 into 1 into 2 by 3 plus 4 into 1. So which is nothing but 3 plus 2 2s are 4. 4 by 3 plus 4. 3 plus 4 7. 7 plus 4 by 3. 7 plus 4 by 3. Go for a cross multiplication. 3 7s are 21. 21 plus 4 1s are 4 by 3. So finally answer 25 by 3. So students, I hope you understand this. Again, this is a 5 mark problem. Totally we have seen 2 5 mark questions. From example 1 question, from exercise 1 more question, remaining sums are 3 marks. So I hope you enjoyed this session. In case if there is any doubt, let me know in the comments. So until you see the next class, it's bye from Parthiban. And students, don't forget to subscribe our Vidyalakshmi YouTube channel. Thank you.